Hello. Today we're going to be covering a collaborative analytics platform that Outlier Ventures has built on Enigma. We're going to go through a case of optimally placing cell phone towers based on a collaborative data set from industry telco providers, as well as classifying the country in which telco customers are based. Now, underlying all of this technology is the Enigma Protocol. The Enigma Protocol is a blockchain-based private compute protocol. And in this protocol, compute logic is defined by secret contracts. These are written in the programming language Rust, and secret contracts are deployed to the blockchain, and their logic is publicly verifiable. So if we're chucking data into them, we can be completely confident that what we expect is being computed is what's being computed, and that our data is encrypted and not viewable by any party that we don't want it to be. In the case of the app we've created here, you can see the contract address here, and anyone can look up the contract and verify this for themselves. So what we're going to do is illustrate two forms of machine learning in a secret contract. The first of these will be clustering. So what we're going to do is we're going to have multiple telco providers submit customer data, and then we're going to cluster on the sum of everyone's data without any individual party's data being revealed to anyone else. So I have a set of example data up here on the left of my screen and the app that we built on the right. So let's say I'm telco provider 1, and I have a couple of customers in London and in Manchester, two cities in the UK. Now I can submit their latitudes and longitudes, and what's happening here is their latitudes and longitudes are being put into the contract state. So these are being stored on the blockchain. And when I'm sending this data, before anything is sent, the data is encrypted and then sent into the Enigma protocol. And the data is only viewable by the secret contract, not by any human or any other party. It can only be viewed and computed on by that contract, whose logic is publicly verifiable. I know exactly what is happening with my data. Let's say I am an entirely different telco provider, and I open up the app again. I am now a small telco provider in the Netherlands, and I have a couple of customers here that I want to contribute to this overall model. Now I can submit these in exactly the same way. I know this data is encrypted and not viewable by anyone else. No one is going to get their hands on my data, and I know exactly what's going to happen with it because I can always verify the smart contract logic. Now, I want to know how to optimally place my cell phone towers. In this event, let's say I have the money to place only 3 towers. Now, I don't know exactly how my customer base is going to look in the future. Some customers might move from different telco providers. In this case, if I'm the telco provider in the Netherlands, it's possible that some of the UK customers might start using my network. However, I don't know when this will be, but I want to compute over the sum of all potential telco customers. So what I will do is I will put in the number of towers I can place. At the moment, I can afford to place 3 towers. I will submit this, and that 3 is being sent to the secret contract on the blockchain. It is computed, and my clustering is then computed on the sum of all data. That is the data from the other provider who's based in the UK, as well as my own. And now I know where to place my cell phone towers to be as close as possible to all of the potential customers. We zoom out a bit here, we can see we have a tower placed in London, a tower placed in Manchester, and a tower placed in the Netherlands, as we would expect. If I only had the money to place 2 towers, then I can check this as well, and we'd probably expect 1 tower somewhere in the middle of the UK and 1 in the Netherlands. And there we go, one tower in the middle of the UK and one in the Netherlands. You can see how quickly the Enigma blockchain is able to process all of this information and compute through our secret contract. It's really quite impressive. That is the first form of machine learning. The second form of machine learning we want to illustrate working in a secret contract is a classification model. And with a classification model, we want to be able to train our model in a collaborative way. So in the case of this application, we have created a model where multiple different parties, these different telco providers, can submit training data to create this kind of super model that has all of the knowledge of an industry. So everyone can contribute their knowledge, and the model can compute on the sum of all that knowledge without any individual party's data being revealed to any other party. So here, what we're going to do is we're going to take a set of training data, and this works in a very similar way. We have a set of latitudes and longitudes with an attached class. In this case, I'm telling the model what to look for in someone who's based in the UK and what to look for in someone who's based in the Netherlands, so it can start to learn what these types of customer look like. And then when it has this data, it is able to classify actual customers rather than just the training data as whether they belong in the UK or in the Netherlands. And there we go, we've submitted this to the contract state. It worked exactly the same way as with submitting data for our clustering up here. It gets stored in the contract state, and multiple parties can provide training data to create this overall training. Now let's classify. And what we're doing now is we're classifying on the real customer data, that is the customer data that was submitted previously by telco provider 1 in the UK and telco provider 2 in the Netherlands. We've submitted separate training data, and now what we're going to do is actually run the train model on the real data that was submitted earlier. And what we'll get is a count of the number of customers in the UK and of the number of customers in the Netherlands. And there we have it, computed very quickly by the Enigma network. And that is collaborative analytics using Enigma private compute.